This is 8.6, day 1, part 2. Now we're going to go on to multiplying and dividing with higher order indexes. So this first example is two radicals. They're both cube roots. Remembering from square roots that in order to multiply radicals together, they must have the same index. So the index in both of these are 3. So we can combine them into one radical. So when you combine them into one radical, the index is still 3, and now you have x to the 7th and x to the 2nd. When we get those together, we get x to the 9th. Remember the properties of exponents, you can add them together, the exponents, if the bases are the same. So now I'm going to break down that x to the 9th into x cubed, and x cubed. Because I'm looking for groups of 3 since my index is 3. Then what's going to go out is an x, an x, and an x. So x times x times x is x to the 3rd. All right, let's go on to the next example. We have another set of radicals that are both index of 4. They're both 4th roots, so we can combine them into one radical. So we have 4th root of x to the 12th times 25x to the 6th. Now we see if we can break down 25. 25 is 5 times 5, and then we have x to the 4th, x to the 4th, x to the 4th. That takes care of those 12. And then I have another x to the 4th and x to the 2nd. Now we look for groups of 4. So x to the 4th root is an x. X to the 4th with that 4th root is an x. Now we have 2 more. The other pieces, the 5 and the 5, and the x squared, are not large enough. There are not 4 of them, so they stay back underneath. So 5 times 5 is 25, and then that x squared. Now I'm just going to clean up that x, 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 and x to the 4th. Then we have 4th root of 25x squared. In 1.3, we talked about dividing with radicals, and we have to rationalize the denominator. So if there are no radicals in the denominator, we're going to do that in the next slides. So here's a couple examples. We have the 4th root of 16x to the 8th over 5. So what we can do is we can split up that 4th root into 16x to the 8th, and then 4th root of 5. Now let's see if we can reduce that 16 down. 16 is 2 times 2 times 2 times 2, or 2 to the 4th. And then x to the 8th can be x to the 4th and x to the 4th. And then we'll just leave that denominator alone. Now, what goes out in front is a 2, an x, and an x. 2, an x, and an x. Over 4th root of 5. So we get 2x squared over the 4th root of 5. Now remember, you cannot leave a radical in the denominator. So we have to rationalize it. So we have to multiply the numerator and the denominator by the 4th root of 5. And what you get when you multiply across is 2x squared, 4th root of 5, and then the denominator, the 4th root of 5 times the 4th root of 5 is just 5. I think we'll skip example B and go down to example C. Hello, this is Pedersen. Yeah. Oh no. I would try to, I'm kind of behind. I'm actually recording right now. I'm going to stop my recording. Was not recording yesterday.